In the last tutorial, we introduced PixInsight's latest and possibly greatest noise reduction filter, Total Generalized Variation Denoise, was written by P-Team member Carlos Milovich and is already proving to be top dog among smoothing algorithms. Just published. Here one demonstrates the power of TGVD as compared with other PI algorithms. Unlike grace duration, TGV Denoise may be used on either linear or nonlinear images, and a two-edged approach may be effective. For those with advanced knowledge of such matters, TGV avoids stair-step and other artifacts because, unlike other anisotropic diffusion-based algorithms, it assumes that images are piecewise smooth. The TGV Denoise process has two separate sections: noise reduction parameters up top and local support settings below. For color images, choose a color working mode. This setting is irrelevant for grayscale images. In RGBK mode, the same settings are applied to each RGB channel and is advisable for linear images. In CIE lab mode, the target image is first converted to the lab color space. When apply is enabled, lightness parameters are applied to the CIE-L component, while chrominance parameters, when enabled, are applied to the A and B components. Upon completion, the image is converted back to the RGB working space. Just as we saw with ACDNR, this ability to split luminosity and chromaticity provides independent control when reducing noise. The larger the strength value, the more aggressive the smoothing. Edge protection is by far the most critical parameter and is akin to ACDNR's edge protection and Gray-C's sharpness setting. A larger value here may result in some loss of detail of legitimate structures. Conversely, smaller values are more protective of edges and will preserve fine detail. The trick is finding a good balance between strength and edge protection. If the sliders aren't getting you where you want to go, adjust the exponents. You'll typically find yourself between -1 and -4. Smoothness is also used to preserve small-scale structures, and the default of 2 generally works well for most images. Default parameters have been optimized for nonlinear images and are too aggressive for linear ones. When using TGVD linearly, try lowering the exponent by 1 order of magnitude at a time. While the default number of iterations is 100, begin with 250, and as high as 500 is recommended for the algorithm to reach convergence. For deep sky astronomical images, especially linear ones, local support is advisable. As with deconvolutions, local deringing support. This is not a mask in the traditional sense, and you're free to use a separate one to further protect regions of high signal. By default, the local support image is disabled, but when enabled and pointed to the target image, its intensity component will be used. Enable preview to see the model. Like ACDNR, this control mode must be disabled prior to actually performing noise reduction. The midtones, shadows, and highlights sliders work identically to ACDNR's lightness mask settings. Lastly, as TGV Denoise is very processor intensive, test your settings on a small preview to speed things up. Try these settings to get started. Enjoy TGV Denoise and stay tuned for future refinements.